So welcome. Thank you for coming. My name is Jesus Camacho Rodriguez. I'm engineer at HortonWorks, working on query processing, query optimization in Apache Hive. And today I'm going to be talking about the ongoing work, basically to introduce. Is this going to continue moving? 1 second. All right, I think now it should be fine. So yeah, I will be talking about our work to introduce materialized views in Apache Hive. So this is a slide that I usually start. This doesn't stop moving. Okay. So yeah, this is a slide that I usually start with to see a bit, to give a bit of perspective, right, where we are coming from with Hive and towards where we are heading and all the work that we've been doing, right? So as probably you all know, I mean, when Hive came up back in 2008, the main use case was batch processing, right? It was mostly or only read data. It was not using SQL. It was using HiveQL that was SQL-like language, but that was giving all kind of interoperability problems. It was about the execution engines. It was relying solely on MapReduce. And then at some point, there is some effort by the community and by some companies where we want to take, I'm just going to move it with this, where you basically want to take Hive beyond its batch. Seriously, I'm sorry about that. Okay, I'll do it manually. So yeah, okay, as I was saying. So there is an effort by the community to take it beyond its batch processing roots, and we wanted to move it towards more like a SQL kind of interactive system. And this effort starts in January 2013 with Hive 0.10. And more than 5 years have passed since, right? So the upcoming release that is Hive 3.0, it will be released in May. So next month, and there has been extensive renovation of Hive internals. Some of them are more visible, some of them are less visible, but the renovation was in 3 axes mainly. That was latency, so we wanted to allow interactive and sub-second queries, scalability, so moving from terabytes to petabytes of data, and also much better SQL support, right? So moving from this SQL-like query language more towards the standard. And so these are just like some of the improvements that went in over the 5 years, right? And there are many more, but there are like some of the highlights. So we moved from MapReduce, and now there are multiple execution engines that are more advanced, such as Test or Spark. There was a lot of work on making more efficient joint execution algorithms. Vectorized query execution was introduced and improved. This will allow us to, or allows us to process batch of columns instead of row per row. So it makes basically LLAP processing much more efficient. And together with this, we integrated with columnar storage formats such as ORC and Parquet. Obviously, LLAP, so live, learn, and process, where you can have persistent daemons for real low latency queries. And also, some improvements that are not like the previous ones related to execution. These ones are more like related to optimization. So rule-based and cost-based optimizer was introduced. Many improvements to statistics, because that's basically the fuel for the optimizer, and also tighter integration with other data processing systems such as Druid. So, but in order to accelerate query processing, what we kind of continue seeing that users are doing is optimizing their queries based on or their database on access patterns, right? So for instance, you have your source tables, and then you will create like replicas of these tables where you change some of the physical properties. For instance, you will distribute it by a certain key, or you will sort it by some other value. Or you also can like create derive tables where you will filter some rows, so you have less data in your tables. You may denormalize your database. So you have some tables, you have some primary key foreign key relationship, and you say, okay, I'm gonna denormalize it, store it in this new table, and I will not have to do some of the joins in my workload. Or pre-aggregation, so kind of summaries for LLAP queries, like you will have some metrics, some dimensions, and you will group by these dimensions and do some precomputation of the aggregates. Now the problem is that people are doing all this, or users are doing all this manually, right? And that becomes kind of a nightmare. These are just like 3 problems that you might encounter if you are doing this manually. So basically you are establishing a relationship between the original and the new tables, right? But how do you know, for instance, if you have if a similar table has already been created, or not similar, but maybe it could meet the same purpose, right? And managing all these tables becomes kind of a nightmare. Rewrite your queries to use new tables. So this, in many occasions, it may not be a problem. In some occasions, you don't want to rewrite all your scripts each time that your access patterns are changing. Also, what happens when they change? I mean, you will have to once again rewrite all your scripts. And also, well, what happens when the original tables change, right? You will have to recreate all these derived tables. Can you do something that is kind of smarter? And these are just, a few examples. I'm sure there are many more where, managing this kind of a scenario becomes kind of a nightmare. So that's where materialized views come into place. Materialized views are obviously nothing new. It's been used in database systems for a long time. Materialized view is an entity that contains the result of evaluating a query, and it has a very important property, and is that when you declare it, it has semantics, right? And you are establishing some relationship between a materialized view and your source tables. And that's something that the optimizer, if it's smart enough, it can exploit to accelerate your query workload. And also, because these semantics are explicit for the system, it can also handle the maintenance in a smarter way. You don't have to rebuild your materialized views completely. You can just maybe pick up the changes, the new changes, and recreate only that part. And yes, I mean, then also what I want to mention is that, the concept of materializations, I mean, it doesn't need to be necessarily a create materialized view statement. The same background applies in many other problems that we find in optimization, right? So you can also have a daemon that creates a materialized view based on like daily activity. A cache result of a previous similar query, maybe within the previous 10 minutes, it's also a materialization, so you can reason about it in the same way. And even within the single query, you might have some parts that can be reused, right? So that's also the same concept of materialization. And at the end, it all relies on the same kind of background of checking whether 2 queries are equivalent, and whether one query is contained within another one. So materializations come in many forms. But right now or today, I'm going to be talking about Hive. this is like an example on how we see it. I mean, it's not the only way that you will be able to use it, but so last year I presented an integration of Hive with Druid. So let's say that you create a materialized view using Hive tables, and you would store it either in Hive or Druid. You use your create materialized view statement, and you will create the views either a DBA or some recommendation system. And then users or the dashboard will send like normal queries to Hive that are based on the source tables, and Hive will be able to rewrite these queries using the views and execute the rewritten query. So that's kind of how the workflow can work. And this is what I will be presenting today. So I will be presenting the first implementation that is part of, or will be part of Apache Hive 3.0, that, as I said, it will be released like next month. It already provides multiple storage options that are transparent for the system, like Hive, Druid. It has automatic rewriting of incoming queries based on these materialized views. And there is also efficient view maintenance, so we support incremental refresh of the materialized views for some of the subset of them of them. Sorry. And yeah, there is also multiple options to control the life cycle of the view. Whether to act differently depending on whether they are up to date in the system or not, and so on. So I will be describing in this talk all these items. So let's start with the like very basic operations of management of materialized views in Hive. So this is a create materialized view statement that we introduce. For those familiar with Hive, or even with any SQL system, but especially with Hive, it looks as any other create table statement, where you can define some properties such as comment, or you can define your row format, your storage handler, table properties, and when you create it, you will define a query, right? That is the query that you want to execute and associated with that materialized view. And you can also see in the second line, enable rewrite and disable rewrite. This is whether you want to enable this view for rewriting or not. We allow users to do this selectively per view. So that's basically the syntax. So just to show an example without all the different options, a very simple example. Okay, we create a materialized view in Druid. We specify that it will be stored by the Druid storage handler, and we specify a very simple query that will be executed, and the result will be stored in the materialized view. That's how it works. It can, I mean, the example is with Druid. If you don't specify anything, it will be automatically stored in Hive. And some other basic operations for the management of materialized views that we introduce. Drop materialized view, that's evident. Show materialized views, so that's just to know which materialized views they are in the system. I think right now it doesn't provide much information, but except the name of the views. But it will probably it will be extended to show some other useful information. And then you can go and extract like detailed information about the materialized view with the describe, extended, or formatted. So that's all very similar to Hive syntax for the tables, right? It's just the same thing. Because after all, the materialized view is just like a table. You can, although I'm gonna be talking today about rewriting and maintenance and so on, you can also select over the materialized view. You can execute all kind of like normal queries. Okay, so let's move to the rewriting. That is, I think, the most complicated and important piece for the materialized views. So yeah, the rewriting, what it will do is automatically rewrite incoming queries using the views, and it will exploit the definition semantics. It's built on ideas presented in that paper that you see below there by some people at Microsoft. And it's implemented using Apache Calcite. Apache Calcite is the project that powers Hive Optimizer. Okay, so other projects may benefit from it too. And right now we support queries that contain those operators. Table scan, project for columns, filter with conditions, join and aggregate operators. And we extended that algorithm that was presented, as I said, in this paper, and with some extensions that are that we find very useful for our environment. One of them is we can generate additional rewritings without doing join permutations. So this is very important for the scalability when you have like many joins in your queries. Basically, in that paper, I think what they were doing is triggering rules to do all possible join permutations. This will not scale. So yeah, we did some work there where we extract some structural information from the plan, and we use it in order to trigger the rewritings without having to do these permutations. And also we have partial rewritings using union operators. So so you understand this. What this means is that, for instance, if you store in your view the results for a certain query for year 2017, but then suddenly comes a query that asks for 2016 and 2017, the optimizer is capable of like kind of reconciliating these results, where you will read some of your data from your view and some of your data from the query execution. And this is also important because it's also the foundation for I will talk about this later, but the foundation for the incremental view maintenance. And yes, if you want more information about what we can rewrite and what we cannot rewrite, you can go to that site in Calcite, and there you will see several examples. They are written in SQL, like create materialized view, query, and then also the rewriting is represented in SQL because it's much easier to read that way. Although the rewriting is done at the algebraic level, right, at the operators level. So now, how do you enable materialized view-based rewriting in Hive? So there is a global property to enable it for all queries, where you will say set Hive materialized view rewriting to true. And then when you create a materialized view, the user can selectively enable or disable it for rewriting, like I mentioned before. By default, they are enabled. And the behavior can be altered once you have created the materialized view by using this statement here. So you can alter materialized view, the name of the view, and then you either enable or disable the rewrite. So let me show you some examples. So let's start with a very easy one, but you will be able to see already some of the interesting properties of the rewriting. So here we have a materialized view definition where you are basically storing all the employees that were hired after 2016 together with their department. And then you have a query where you only ask for employees that were hired last quarter. So you can see that the filter condition is within a range in first quarter of 2018. So in the materialized view rewriting, what you can see is that we can basically check containment of the predicates. So we will the optimizer will realize that the contents of the query are contained within the view, or the predicate that we are asking for, and it will add this on top of it. Will be scanned on the materialized view, then it will add some filter, and yeah, that's how you will get the results. So if you look at the sample data, you can see that you will basically filter the contents of the view to get the query results. Okay, so that's a simple example, but you can see already that how these filters and the containment can be interesting, and it can be exploited. Now let's move to a slightly more complicated one. So you have this schema up there, right? That is a star schema where you have line order, and then you have four dimension tables: part, supplier, customer, and dates. And now let's say that you store in your materialized view, basically you will store the denormalized data. So you get your line order, and you will append every part and supplier and customer and dates. Now, you know that, Hive 3.0 also introduces, one of the things that it introduces is constraints, such as SQL constraints. So you can define primary key, foreign key, unique key, and not null. And the optimizer can also exploit this information. So this join, basically, it will not change the multiplicity of the table, of the line order table. What it is doing is just appending columns, right? So then when the query comes and the query is asking only for two tables, line order and dates, it's doing some join and some filter, the rewriting will be able to use the materialized view because of this property that I told you. You can just read from the materialized view and project what you need, because you know that you will have all the information that you needed in the view. So you apply some filter on top and some projection and some aggregation, and that's it. So that's something that is also interesting and can be useful, because a lot of the scenarios that we see, people tend to denormalize some of the tables, but then your queries may not ask for information from all of them. So that's also an important use case for us. And the last example that I will show about rewriting is more like related to Druid, and it's related to rollup. So now it's a simple table, wiki, where you have some time, some events, character added, characters removed. And you are creating a materialized view where you are basically summing all the characters that were added and removed per minute, right? Because you create this materialized view probably because you think, okay, I'm not gonna need anything at a granularity lower than the minute. I don't care about the seconds, so I create this materialized view. Now, when the query comes, you want to get, for instance, the characters that have been added per month. So you have to roll up your data. And the materialized view rewriting can also detect these kind of functions. And as you can see, it will roll up by month. It will read the data from the materialized view, roll it up by month, and sum the characters. So you can see there in the contents how we can basically infer the query results from them. So these are like 3 examples that I wanted to show. There are many more, and I'm sure that with the feedback also we'll get much better. So yeah. So let's move on to the maintenance. So maintenance is a very important step because you want to make it as efficient as possible. So right now the rebuild needs to be triggered manually by the user. So the user, if you have inserted new data into your source tables, you will have to trigger this rebuild command manually, alter materialized view, the name of the view, and rebuild. We support incremental view maintenance. What this means is that we will only refresh the data that has changed in the source tables. So we will not rewrite the full materialized view if it is not needed. And this is complicated, but it brings multiple benefits. The first one is that you decrease the rebuild step a lot, right? Because if you have just inserted a few rows, but you are talking about, I don't know, 1 terabyte of data, you just don't want to process the whole thing again, right? You just want to append these rows to the materialized view. And also a very important aspect for Hive that is very Hive specific is that it will preserve the LLAP cache for existing data. So to explain this is like, if you would do a full rebuild, you will wipe your cache for the materialized view. If you just append new data, you basically just need to load this new data into LLAP, and that's it. You continue running. So that's why it is very critical for us. Now, in order to run the incremental view maintenance, you should only use transactional tables, either micromanage or ACID. This is important. This is because you basically need to be able to identify what has changed. And you cannot do this with all kind of Hive tables. So you need to use either micromanage or ACID for your source tables. And the current implementation only supports insert operations. If you have an update or a delete operation, we will actually fall back to full rebuild. And then finally, the optimizer will always attempt to do an incremental rebuild, But if it doesn't succeed, it will rebuild the view, but it will do it with a full rebuild that is equivalent to an insert override into the materialized view, right? So how does this incremental view maintenance algorithm works? I mean, here it's related to the union rewritings that I was describing before. So when you create a materialized view, you store a write ID, or when you refresh it. And this write ID, the important thing, is that it associates each row with the transaction. So basically, if you know your write ID, you know which contents are in the materialized view and which contents are not. And then when the rebuild is triggered, we introduce a filter condition where we say, okay, we want, for instance, write IDs that are greater than 1,000. And the good thing is that that way we will only read new rows from the source table, but the really cool thing is that the rewriting, the one that I was describing, the materialized view based rewriting, can kick in because it's like a normal filter, right? It's like you're filtering by date or any other column. So we basically rely on the same rewriting algorithm. And then we'll rewrite this insert override on the materialized view into more efficient insert if there is no aggregate on the materialized view. If there is an aggregate in the materialized view, we use we do this at the algebraic level. From SQL, it would be the equivalent to a merge statement, where you will update some of the rows, the ones that were already in the view, and you will insert some new ones for the values that were not there. So very briefly, with an example, maybe you will see it better. So this is same kind of example as before with the wiki, where you are grouping by page and user, and you are summing up the characters that were added and removed. You create your materialized view that has those contents, and then 2 new records arrive, right? One for Miley and one for Justin. And now you have to, you trigger your alter materialized view rebuild because you want to rebuild your materialized view contents. Now, this is the rewriting that we produce, where, I mean, the takeaway here is that you have a part that comes from the view, okay? And you have a part that comes directly from the tables, where the write ID is greater than 999. That is when we created the materialized view the first time. And then you roll up your data. So this insert override is correct. And that could do a full rebuild of the materialized view. You consolidate the view with the new data, you roll it up, you insert override, and you're done. But what we do is that we attempt a second step where we basically take the part that is coming from the table and we put it into like equivalent to a merge. And then if there are rows that match, like Miley, we will update the values. And if there are no rows that match the page and user, like Justin, we will insert a new row, right? So this is, I think it's fairly complicated, but the takeaway here is that we don't need to do, even for queries that contain aggregates that are more complicated, we don't have to do a full rebuild. And we will only update the data that needs to be updated. So that's the important part here. And also that it relies on the rewriting is very important for us, because yeah, it's much easier to handle everything. Okay, so moving on to the life cycle of the materialized view. So how do we control stale data right now? So right now we do not accept stale data in the materialized view, which means that if you create a materialized view and you insert some data in your source tables and the materialized view is outdated, you will not use it by default, which is what you would expect, right? Because you would expect to get the fresh or the right results. Still, it's possible because of the kind of rewritings that I was describing that the materialized view is used, because you might read the old contents from the view and the new contents from the table. This can happen, but yeah, that's the default behavior. We do not accept stale data. Now, you can change some configuration parameters, and you can say, okay, I'm okay with some staleness. And in this case, what you do is define the freshness of your data as a time parameter. And what this means is basically you will set some time window, and you say, okay, if the materialized view was not rebuilt for this time window, and there were some changes in the base tables, then I will not use it. So how do you do that? First of all, you set a property, time window property, where you can say, for instance, 10 minutes. So basically, if your view is outdated by more than 10 minutes, do not use it. It can also, more useful, it can also be overridden for materialized views individually by giving this property in the table properties when we create the materialized view. And then you can basically trigger the rebuild, for instance, every 5 minutes. So like that, you know that you are always, your system will always, or your queries will always be hitting the materialized view, and you know that your view will never be outdated for more than 5 minutes, right? Kind of. So it gives you certain warranties. This is not, I mean, this is like work in progress. This is what we have right now. We also want to add, obviously, or we are exploring ways of adding one mode where, inserts or modifications to your source tables automatically update also your view. But that's also challenging because you want that approach to scale. What happens when you are, for instance, streaming data into your source tables? You will have a real bottleneck there, and maybe you don't want to penalize all the inserts that way, right? So we're kind of exploring different options there. But yeah, this is what will be part of Hive 3.0. And yeah, let me conclude with what we have in front of us. So in the short term, let's say shorter term, or more incremental improvements for the views, we have to assess the rewriting performance and scalability under stress conditions. Let's say when you have many materialized views in the system. This is quite important. We have some ideas on implementing some kind of pre-filtering techniques, so you basically don't attempt to rewrite almost with every query, with every view that is in the system. We also want to provide a way to, this probably will be part of 3.0, to control the physical distribution of your data. So right now you cannot do that, but it's one of the use cases that we were targeting, where you create your materialized view like I was describing before, but you will indicate that you want to sort it by A, or I don't know, cluster it by year or by month or anything, right? So you don't have a way right now to control that physical distribution of data, but we think it's very useful, and the optimizer also will be able to exploit this to choose like the best plan. And also increase the incremental view maintenance coverage. So as I mentioned, only inserts are allowed in the source tables, otherwise we have to go back to full rebuild. So yeah, we want to also support updates and delete in the source tables. Things become a bit more complicated, especially when you have aggregate operations or group by in the materialized view, but yeah, we want to do that. And also one piece that we think it's very important, that also it fits well in the whole like description and goals that I was giving you, is a materialized view recommender, where you have a query workload and you give it to us and or to the system, and the system can say, okay, under certain constraints, like I don't know, disk space, these are the materialized views that you should create in your system in order to accelerate query processing. So that's something that we will be working on. Will not be part of this release though. And yeah, that's it. This will, I mean, it's not, if you go right now, it will be empty. But there is where we will, once 3.0 is released, is where we will describe everything that I have been talking about today from a more formal perspective. Also stay tuned, because I thought that I would be able to show some numbers, but basically 3.0 release finally was later than I thought. But stay tuned, because we will be posting something to the blog. some numbers and also some kind of experiments that you can like reproduce in your own environment. And I think that's it. I thank you for coming, and if you have any questions. Yeah. Say that again, say that again. So you have your source tables partition. Mhm. Yeah, so that's what I said. So that's something that we do not support right now. That's that's what I showed in the last slide. So that's what we want to do, right? That right now it's like when you create the materialized view, it's purely SQL, and we want to give this kind of tuning that you can do in Hive with tables, that you can also do it with materialized views. But it's not there yet. So the one that will come straightforward, I think, is cluster, sort, and distribute, because it doesn't change like the layout of the materialized view. It's just, it just changes the layout of the data. Partition is a bit more tricky because, you will create like different folders, but we want it, we want that it supports that too. So the one that I think will be more immediate are those three, and then, yeah. And then once you have that, yes, the optimizer should be able to exploit this in order to choose to read from one view or another. Yeah, that's the idea. Yeah. You mean by default? No, it is right now it is the default. So well, to be honest, there is certain parameters. So you can also tune how you are, because this was also very. So let's go back. One thing that we want to do also for 3.0, but I don't know if we'll have time, is that we need a better way of debugging why the materialized view rewriting algorithm was not triggered, okay? And because of that, we introduced one parameter where you can basically set up how the rewriting is gonna be chosen. So either cost-based, by a heuristic, or always. And right now it is, by default we use a heuristic, where most of the times, I think you will trigger the partial rewriting. Sometimes it might not, that's the default. I guess if you ask me if sometimes it might not be useful. Yeah. Yeah, so that, yeah. So this, it will still do it. It's not, but still, it's a cost-based decision. So if you ask me if there is some occasion where maybe it's better to not read from the materialized view, I'm certain there is some corner case, right? Where maybe you are reading really a few rows from it, and it's just better to not do the union and also the roll-up on top, for instance, because roll-up is expensive. But yeah, it can definitely trigger it in both scenarios, yeah. Yeah. Okay. You mean to, so say that again. So you mean when you rebuild the data, if we use, yeah. So you can do this rebuild can be incremental, if that's what you mean. You can just, there is no restriction on whether this is incremental or not. You mean how we trigger it? Or, yeah, yeah. So you rebuild every 5 minutes, and your time window is 10 minutes. So you are sure that if queries come at any moment in time, you will be hitting your view. It's just that you know, you are kind of doing micro batching, right? Because you will see, like, every 5 minutes, your materialized view will be updated, your data will be updated. So for the users that are hitting with queries, it's like micro batching, right? But the good thing is that there is no performance penalty, because you will continuously hit the view, even if there are inserts in your source tables. So, okay, so I will be here for these 2 days. So if you have any more questions, just find me. Thank you.